Welcome back friends. Welcome back in another video tutorial for microbiology with Shagnik. So today we will going to talk about another video on our mechanism of various type of enzyme, how enzyme act we will going to see in this video lecture series. So today another edition that is about ribonuclease A. So without any further delay, let's get started with the video. So ribonuclease A is a enzyme which comes under the category of ribonuclease or RNase, and it is a group of enzyme whose main target is to hydrolyze the phosphodiester bond between ribonucleotides. Okay, so there are various type of ribonuclease available. For example, RNase N, RNase 1, RNase 2, 3, RNase H, RNase A. Both all are reported in both prokaryotes as well as eukaryotes. So, the most studied ribonuclease, which is ribonuclease A, we have already discussed another type of experiment in case of protein folding, if you remember, with RNase A, which was isolated from bovine pancreas, and here also we will going to isolate RNase A from bovine pancreas. So here this bovine pancreatic RNase have the ability to break the phosphodiester bond or to hydrolyze the phosphodiester bond in between two ribonucleotides. Among them, one should be made up of pyrimidine nucleotide, and it will give us 3' phosphate and an RNA fragment with 5' hydroxyl group. Okay, so let's get started with the video where we will going to see the mechanism how this RNase works. So if you remember, we have started this video lecture series with one kind of serine protease that was chymotrypsin, right? And in that particular video, what we have talked about? We have talked about that the catalytic mechanism of chymotrypsin is mainly driven by serine, which is present at the 195th position, right? And along with that, two and more amino acid act as a assistive role. They are histidine 57 and aspartic acid 102, right? And they will together create a catalytic triad that act as a charge relay system, and that's how they work. In case of aspartate protease, that was our video number 2, we have discussed that two aspartic acid together driven the catalytic mechanism, right? Where their carboxyl group assist in proton donor from the from the water, right, which will going to act as a nucleophile, right? Now here in RNA, two histidine will going to take part. One histidine present at the 12th position, another histidine present at the 119th position. So in the first round of the reaction, histidine 12 will going to act as a base and histidine 119 will going to act as a acid. And in the second part of the reaction, histidine 12 will going to act as a acid and histidine 119 will going to act as a base. That means there is a interchange in role in between histidine 12 and histidine 119. Okay, so first I want to clear one thing, that base will going to accept a proton, okay, whereas the tendency of acid is to donate a proton. Okay, make it very clear. So as I have told you that base will going to accept or take a proton, so what base will do? Base will abstract proton from the 2' OH group of the ribonucleotide. Okay, so that's it's what here it is doing here. Okay, and as a result, what will happen? It will create a nucleophile at the 2' position of the nucleotide, and this nucleophile will going to attack this phosphate. And in the meantime, as I have told you that this histidine 119 will going to act as a acid, and the acid's tendency is to donate proton. It will going to donate this H to this O. Okay, and obviously there will be N remains, and due to these two proton donation and acceptation, there will be generation of a 2', 3', cyclic nucleotide, and this part will be liberated having a 5 prime OH. That's what I have told you during the starting of this video, that one 3 prime phosphate will be generated, along with that 5 prime remaining RNA fragment will be generated having a 5 prime OH group. So this part is the remaining fragment having 5 prime OH group, right? So now in the next part of the video, there will be a water molecule that will come. And as I have told you that this histidine 119 will going to do what? This histidine 119 will going to take proton here. Matlab, meaning this histidine 119 will going to act as a base here. And in the meantime, histidine 12 will going to act as a acid. So it will going to take proton, so it will going to take this proton, and as a result this O becomes a nucleophile and it will going to attack again this phosphate. Okay, and during that time this histidine 12 will going to act as a acid and it will donate this proton to this O, and as a result the bond between the O and P will be broken. Okay, and as a result 2 prime OH group at this nucleotide will be regenerated, right? And here again there will be a presence of H, and that's how the entire reaction will be completed, giving us 3 prime nucleoside monophosphate. So that's the idea. So first histidine 12 will going to act as a base and take the proton, and histidine 119 will going to act as an acid and it will donate the proton. And then in the next part of the video, role will be interchanged. Histidine 119 start acting as a base and it will start taking the proton, and histidine 12 will going to act as acid and it will donate the proton. That's how the entire thing will be going on in case of ribonuclease A. So I hope this mechanism is very clear to you now. So thank you for listening to this class.